So next video is on problem 4 of the Project Diver series. So this one is the largest palindrome product. So right here. Now a palindrome is a number that is the same forward as it is backwards. So for example 9009 or 99 is also a product, a palindrome. So any number that you could basically mirror, same forwards as same backwards. You can see here I've already got the answer, and the answer indeed is a palindrome 906 609. So yeah, hopefully you understand this. Now the question is, what is the largest palindrome that can be made by multiplying together two 3-digit numbers? So the way we're going to do this, now we could just multiply all the numbers together that are 3 digits, create a huge array of all these numbers, then say loop through each one of them and say is it or isn't it a palindrome. Then if it is a palindrome, add it to another list, keep another list of all these palindromes. Then when we find the list of palindromes, we could say which one of these is the biggest, and then when we find the biggest one, we know we've got the answer. So that would work, but there's better ways to do that. So what we're going to do here is we're going to say, okay, so we're going to say biggest palindrome. I'm going to set that equal to 0 since you don't know it immediately. Now what we're going to have to do here is we're going to have to loop over a set of numbers. So we're going to end up in a situation where we get x times by y is equal to something, and then we're going to say if something is palindrome, then we could add it to our list of palindromic numbers, and then in the end check if it's a maximum. There's a few clever things you could do, so you wouldn't need to actually do that, but we will do it that way just for the sake of making it look a lot easier. So we're going to add to list, and then at the end we're going to loop over list to find maximum. Actually, we're not going to do that. We could just call the max thing. So we're going to say max of list. You'll see all these are keywords and stuff because I'm not actually using things properly, but here's the basic idea. So we're going to need something to generate x, something to generate y. We're going to need to multiply these together to get a number. We're going to say if that number is a palindrome, so we're going to need some way of checking for a palindrome. If it is a palindrome, add it to the list, and then at the end we're going to say what number is the biggest in that list. So this is going to be the first one where I write two functions. So I'm going to write a new function down here called define is palindrome. Now I'm going to do this purely because it'll teach you how to use two functions. You don't actually need to do it this way, but I'm going to. So I'm actually spelling palindrome wrong, I've just realised. Thought it looked a bit weird. So what we're going to do here is we're going to pass in an argument. We're going to pass in number to test. So this is going to be a test number. Now we've never passed in an argument before. You see these parentheses or brackets are empty. When you pass in a number, this is basically passing in something that you can use in the function. So we're passing in test. Now if I print test, so I'm going to call main down here like we always do. Now you're going to see when I call main, this will do nothing at all. So this function is going to run look, and it does nothing. So the reason being, I'm calling main. Main goes in up here, and now all main does is set biggest palindrome equal to 0, and then exit. Now Python, when it sees a script like this, what it does is it reads define main, and it goes right, great, that's where main is. If main's ever called, I know where to go. Now it skips this line. It doesn't actually read this line. It goes down, checks the next line, next line, next line, gets to define is palindrome, and it says right, is palindrome that function? That's right here. So if I ever need to know where that is, that's right here. Now it skips the next line, doesn't do this print, it skips that, goes down, down, down. It says, right, main's just been called. And it goes, hold on, I know where main is. I defined that earlier. So it knows where main is. So it's going to go back up here. It's going to go inside the main function because that's just been called. And it's going to set biggest palindrome equal to 0. Now, that's been set to equal to 0. Now it's going to exit the main function because there's nothing else here. And it's going to go, right, we're done. So you'll see at no point did it enter this function is palindrome because it was never called. So we need to call that function. So we're going to call is palindrome. And we're going to pass in. So say we wanted to test the number 100 and we want to say, is this a palindrome? Now, is palindrome obviously doesn't test for palindromity? Yeah, if that is a word. Don't have a clue if that's a word, but maybe it is, who knows. So what this is going to do, we're passing in 100. Now when we pass in 100, we're putting this in as the first argument, or the first argument we've labelled test. So hopefully you see now this 100 is going to be redefined as test. So we're setting test equal to 100. This is now going to be printed. So hopefully this is going to print out the number 100 when we run this. And you can see indeed we do get 100 printed out. So hopefully you can see now that this function is being called because we've called it up here. We're putting in 100, so it's printing out 100 because that's what it does. So what we want this function to do, instead of printing out the number, we want it to take this number and say, is it a palindrome? If it is a palindrome, so if test is palindrome, return true, else return false. So these are return functions right here. What these do is these will mean that when this function's called, it's going to actually set something. So I'll get to this in a bit. This won't make too much sense right now unless you know what you're talking about with this stuff. But basically you need to return something for it to instead of just doing something. So this down here is just calling the function main. We're not actually setting anything equal to main or anything like that. So main never needs to return anything. You'll notice in none of the other scripts I've done, I've never returned anything from main. But when you have multiple functions, generally you're going to want some functions returning values, not just executing commands. So in this case we're going to return true or false because we're going to say if test is a palindrome, return true. It was a palindrome. If it's not a palindrome, return false. So what we're going to have to do here is write this thing that's going to check if it's a palindrome. Now, for it to be a palindrome, it's going to be the same forwards as backwards. So we're going to say if test is equal to test in reverse. So the way we can test for that is we can do this little command here. So if I stop calling this function now, I'm going to stop that. I'm going to say, actually I'll call, so I'm going to say palindrome. I don't know why this keeps going to 2. Oh, that's because I've wrote it up here. So palindrome equals, so we know 1, 2, 3 is not a palindrome, but we're going to say it is. We're going to print palindrome. If I just run this, you'll see we actually get 1, 2, 3 printed. Now, if I wanted to print this in reverse, what I can do is I can say print palindrome -1. Whoops, I can't do that. I need to print, so instead of printing the int version, I need to print the string version. So if I say this is a string instead, now you'll see I can print it in reverse. So I'll get 1, 2, 3, and then I get 3, 2, 1 from doing it in reverse. So what it does is it takes, I'm leaving these first 2 arguments empty. These first 2 arguments are, if you remember from the previous videos, you can put arguments in here to start at certain values and end at certain values. But we want to do the full length of the string, so we can leave these empty. And now our step, so this is like the range function we talked about. So when we had range and we had like a start, so we had start of 1, end of 1,000, and we could have a step of 2. You can think of it similar to this. So we have a start value, an end value, and a steps. Our steps -1, which means we're going through it backwards. So if you go through a range -1, you actually start at 1000 and you go backwards through to 1. Well, you don't start at 1000, you start at 999 since you don't. Yeah, but you get my point. -1 goes through backwards. So what we can do is we can say it's only a palindrome if the reverse version is the same as the forward version. So we're going to get rid of this and we're going to say up here we're going to redefine test equal to the string of test, because this function only works on a string as we've just on a string as we've just found out up here where we hit this error. So str and then passing it an argument makes the argument a string. So if I print test right here, and then I print test again right here, and then I call that on 100. So you see we get the same thing each time. Now if I print, you can call the function type to return what type it is. So I'm going to print the type of test, and I'm also going to print the type of test here. And now you see we get 100, and that's an int, and then we get 100, and that's also that's a string. So you see our conversion did actually work to a string right here. Type just returns the type of it, so you've got like int, strings, floats, objects. There's many other types in Python, but type just tells you it. It's quite handy to know for like debugging purposes and stuff like that. So yeah, convert it to a string in case we're passing in an int, which in this case we will be. And then we're going to test true or false. So what we're going to say is, because this is returning a value, we're going to say print whatever that value is. So we're going to print either true or false. So it's given us false for 100. Now 101 is a palindrome because it's the same forwards as backwards, so we'd expect true, and you can see right there we do actually get true for 101. So you can see our little function down here for testing for a palindrome, that's working. It's returning the right thing. So if I put 100001 in there, we'll see if that's a palindrome, and you can see indeed it is a palindrome because we have 100 and then we have 001. They're the same as they are forward and backwards. So now we've got our function to test, is it a palindrome? We need to say, we need some function that's going to generate all the numbers we need to test. So if we go back to the original question, you can see the numbers we need to check are products of two 3-digit numbers. So we need to generate every 3-digit number once, and then we need to generate every 3-digit number again, and we need to cross multiply every single combination, come up with all these huge numbers of products of numbers. Basically there's going to be a huge list of all these numbers, and then we need to test which ones are palindromes and which ones aren't. The ones that are, we're going to add to our list. The ones that aren't, we're not. So list of palindromes is equal to an empty list. Now what we're going to do is we're going to say x equals now we're not going to do it this way. What we're going to do is we're going to say for x in range, and then remember we're doing all 3-digit numbers, so we can start at 100, just 100. We're going to end at 999, so this can go up to 1000. Now that loops over all the 3-digit numbers once, so then we're going to say for y in range 100 and 1000. We're going to print xy here, and I'm going to make these numbers really small, so these are going to be 10, and we're going to go from 1. So you're hopefully going to see, actually we'll make this 5 because this is going to print a lot of numbers. So hopefully you're going to see what's going on here. So when we first go into this, we have x equal to 1, so then we enter, and then we say for y in this range, so y is going to equal to 1, so we're going to print xy, so we're going to print 1 1, as you can see on the first line. Now once we printed 1 1, we've exited this, so we're on now this line right here. Now there's nothing here and there's nothing below it either, so we go back into this for loop right here, the for y. Now y gets iterated up to 2, so y is going to be 2, but x hasn't been iterated again, so x is still going to be 1. So we're now going to print out 1 and 2, as you can see on the next line. This is going to go on until y reaches 5. When it reaches 5, we actually reach out the end of our range, and we say, right, get out of this for loop. We've finished this for loop now. So we finish this for loop, and we go back into the x for loop. X gets iterated to 2. And then once it's iterated to 2, we come back inside here, and we say, right, for y in range 1 to 5 again. And we just repeat the process. So we get 2 1 printed out, 2 2, 2 3, 2 4. Then x gets iterated to 3, 3 1, 3 2, 3 3, 3 4. X gets iterated to 4, and you can see what happens here. So for every time x gets iterated once, y is going to be iterated over again a whole new set of times. So you can see our x's are printed out 1 1 1 1, 2 2 2 2, whereas our y's are printed out 1 2 3 4, 1 2 3 4. So you can see we're getting every combination here. Hopefully that makes sense. So we're going to go back to 1000, 100, 1000, 100, and obviously I'm removing this print now because that's going to be a huge set of numbers. Now what we're going to say is, if x times y, and now we need to check, is it a palindrome? So if okay, so I'm going to do this differently. What I'm going to do is I'm going to say number to test is equal to x times y, and now I'm going to say is palindrome, is palindrome number to test. So hopefully you see now we're going to multiply x, y, we're going to call this number to test, and then we're going to run our function that returns true or false on that number. So we're going to return true or false. So what we're going to say is if, and hopefully you see that when we return true or false, it'll be if and then a true or false. So if it's true, we know we've just found a palindrome, so we want to add this palindrome to our list. So list of palindromes dot append number to test, and now if it returned false, it's just going to skip that. It's not going to enter here, and we don't need to worry about it. It's just going to jump to the next number and test it. So at the end, what we want to do is we could print our list of palindromes. I'll do this. It's probably going to be quite a big list, but I'll do it. So you see right here, this is actually working. We've got a huge list of all these different palindromes. You see every one of these is actually the same forwards as backwards. So you'll also notice they're not in order. We have 5 here, like 580,000 here, 514,000 here, but then 906,000 here. So these aren't in order. We can't just take the last element. What we can do instead is we can call a function called max. We can call this function on our list. What this does is it just returns the biggest value in the list. So it returns the biggest value. So what we're going to do is we're just going to print that biggest value, and you'll see here we return 906,609, which actually was this third last value, and you'll see it is actually the answer. So that's the answer. If that's all you're interested in, there you go. But I'm just going to go over a couple of extra things because there's a few improvements you can make to this, a few things you should probably note. So this number to test equals x times y. This was completely pointless typing this in here. What we could have done is get rid of it and put it in here. There's no need to add extra variables when we really don't need them. So yeah, can if you want, but it's easier. You can delete a line just by putting it in there. Now we didn't actually need this extra function. I'm still going to leave this in though because it keeps the code quite clean. But we could have just said down here if test equals test in reverse. So instead of calling this function, what we could have said is, if I comment out this line, I'm going to comment out this line, and we could have had this here, and we could have said if x times y is equal to x times y in reverse. Now we would have had to convert these to strings, so we'd have said string xy is equal to string xy in reverse. Hopefully that makes sense here, and then we would have list of palindromes dot append, but then we would have wanted to append the int version. This is why I did it with the extra function, so we would have like not had to do all this conversion. But if you follow along with this, you're going to learn quite a lot of things. So we then would have appended that, and now if I run that, you'll see we get the same thing. And obviously we don't now need this function, so comment this out. We could have deleted this if we wanted. So you can see we've done this in 1, 2, 3, 4, 5, 6, 7, 8 lines. Another thing we don't need, this biggest palindrome was a completely redundant variable. I was going to be using that, but I decided not to. So you can see, how many lines is this? So 1, 2, 3, 4, 5, 6, 7, 8 lines, and it's done. Now, another thing we could have done is, so I'm going to get rid of this because I actually prefer using the extra function way. I think it's a lot easier to understand, and it's not always better to have your code shorter. I would definitely go for readability in cases where it's not impacting on performance, which this isn't. There won't be a huge performance loss from calling this extra function. So one thing we could have done is we could have went through this range backwards, and we could have said when we find a palindrome that is, say, in the 900,000s, make that our biggest one, and then only check ones that are that big, only check numbers that are that big, basically so that you only find the biggest one. So you're not finding them all and then checking which one's the biggest one. We could have also, you'll notice in this loop here, we're going to set x equal to 100, and we're going to set y equal to 100. Y is then going to go up all the way through the range. Then we're going to say x equal to 101, and then y equal to 100 again. So you're going to get, I don't know if I've explained this very well, I probably haven't, but you're going to get basically copies of numbers. I don't know if we'll be able to find one in this list, because this list's huge, but there's going to be repeats. You're going to get a lot of numbers in here twice. Let me have a quick look, see if I can find one. So 102,001. We probably won't be able to find one because just purely how many numbers there are, but you're definitely going to be doing things again here, so there's no need to do 101 times 100 as well as 100 times 101. So what we could do is, instead of looping from this range, we could loop from x up to 1000. Now this isn't going to impact massively on performance. If I actually import time, so whenever you're using a different module than the standard library, you need to import it. And I used this at the end of the last video and didn't really explain it, but it's not really that important. It's just you might like to time your own stuff. So this here is going to, when the function starts, we're going to set a variable equal to time.time. Now time.time just returns the time. So if I print out time.time, so you can see what it returns. It's the number of seconds that has elapsed since it's like 1970 or something, when, like, I don't know, Google it, you'll see what this does, but basically this is the number of seconds since something. I can't remember what that something is. But yeah, so we're going to set them number of seconds equal to start time. Then at the end, once we've finished our thing, we're going to print out time.time minus start time. So this is just going to take the current time, take away the time it was at the start when we started running the script, and it'll print it, and you'll see that actually gives us 0.46 seconds. So this took nearly half a second. I'm just going to run it a couple of times just to check that's accurate. So you can see 0.45, 0.46. It's pretty accurate around that. Now if I change this to X, you see we've dropped that down to 0.2. You see we've like almost half, well we have half the time it takes to run. Now I may as well do this just to check what the actual impact of this was, but I can't imagine it was much. So if string x times y is equal to string x times y in reverse, and then we're going to say list of palindromes append. I added the int thing in there before, but you don't actually need to do that because we're not actually changing x and y here, we're just saying the string version of them. Hopefully that makes sense. Okay, so if I run that, you see this is actually longer, so it was quicker to make it in a separate function. That's interesting. I didn't actually know it would be. I thought it had been the other way around. That's definitely the case. Look, this is definitely consistently slower than the old one. So maybe it's to do with the conversion of the string twice. We're converting it once here, and then we're converting it again here. Whereas down here we only convert it once. So that's really interesting to know. I didn't know that would be the case. So it was actually quicker the way we chose to first do it, which is even better to read as well. So even more reason to lay this out in two separate functions. So hopefully this makes sense to you. Hopefully you understand what we're doing, why we're doing it. This video has definitely been longer than it needed to be, but hopefully you've learned some stuff here. One more thing about the time module and like doing what we were doing down here. You'll remember in the last one I printed out, so that this isn't actually to do with the time module, this is to do with text, but I printed out time taken. I can't remember what I named it, but time taken. I did these curly brackets and you see the term purple, and then I said dot format, and then I said time.time minus start time. So what this does, this is text formatting. I'll quickly go through this because it's really handy. So when you print, if you put it in quotation marks, you're just going to print actually what you're typing. So you'll see when I print this. Whoops. Am I missing some brackets? Yeah, I'm missing some brackets on this print. Whoops. That was why I was missing the brackets. I typoed in the thing. Okay, so you see what I'm printing here is time taken. So that was actually what I'd typed, and then I'm not printing these curly brackets. Instead, what I'm printing is the value of time.time minus the start time. So what format does is it fills these curly brackets with arguments that you're passing in here. So if I print, if I put another set of curly brackets in there, now I need to pass it another argument. So I'm just going to put a comma in here to pass in another argument, and I'm going to say we're going to print out. I'll print out the list of palindromes. No, I won't. That's going to be really long. I'll print out the max list of palindromes. So we're probably going to get the answer at the end of here. So you see, now we're getting the first argument printed out, then a space because there's a space between these curly brackets, and then we get this argument, the max list of palindromes. We get that printed out right at the end. So if I was to take out the space, you'll see they get printed out right next to each other. You see that's horrible to read, but it is there, 9066009 right in the end. So really handy. It saves you having to, because a different way you could do this is how I used to do it before I learned how to use the format thing. So I would say time taken, and I'd put a space, and then close that off, and then I'd be printing out an argument. So I would say time.time minus start time and then say if I wanted to print out something else, like what our answer was, and I'd need to put a space, and our answer is, then another space, I'd need our answer, so max list of palindromes, then I need to close all these brackets, and now you'll see this is actually right, time taken, and then there's two spaces for some reason. Does that auto put space in for you? Okay, so it does actually auto put a space in, and I'm not sure why. I'm sure it never used to do this. So it must automatically put space between arguments, but even so, you can see what I've had to do here. I've had to pass an argument of this string in. Whoops. I've had to pass an argument in of this value right here for the time. I've had to pass another string argument in, then another argument in here that's going to be the answer to print out this little line right here. Now another way you could have done this is using the string formatting, so I could have said time taken, I need to add the n in there, so time taken, curly brackets, I could put a comma in there, and I could say, I won't, I'll keep it exactly the same, so time taken, and our answer is another set of curly brackets, and you say dot format, and then we've got to pass in the time.time minus start time, and the max list palindromes, and close off all them. You see we're going to get the exact same thing twice, but I personally really prefer this bottom one, even though it's longer because of the dot format that you need. It's not significantly longer, and it's way more readable. You can see we can read out exactly what we're printing here, and we know, right, we've got a curly bracket here, I wonder what that is, we've got a curly bracket here, I wonder what that is, and we go, right, we've got a dot format, so what's the first argument? Here's the first argument, that must be our first curly bracket, then we've got our second argument, that must be our second curly bracket. So yeah, that's just a little bit on string formatting, definitely worth learning, but not vital to be able to do these project Euler stuff. So yeah, if you're interested, there it is. That's it for this video. If you like this video, leave a like. If you want to see more of this sort of stuff, subscribe. If you're stuck, if you need help, leave a comment below. I'll definitely get back to you and help you. And that's it for this video. Thanks for watching. I will see you in the next one.